All right, okay, so let's do a proof. This is a very interesting one. It attracted a lot of my attention because this is one of the indeterminate form of 0 divided by 0. And it's a classic because if you don't know this, you're going to stuff after uni. So, limit when x approaches 0, sine x divided by x equals to 1. Well, obviously, we can't just sub it in because sine 0 is 0, then 0 is 0. So 0 divided by 0 is what? Mm, it, it, 0 divided by 0, it could be 1. Who knows? It could be 2. If we wanted to. I can make an equation that let it be 2, but that's another video. So, however, we know we can't take the limit, we can't just sub the values in directly, but it doesn't stop us taking the limit. So that's what we are going to do today. So first thing first, in order to prove the limit, we need a basic unit circle to help us. So if you know the area of any segment of the unit circle is pi on 2, then that's great. If you don't, search it up. Then the next bit is we're going to use something called a squeeze theorem. Sounds so interesting. What's going to happen is that we're going to say that the area of these blue triangle, which is the inside unit circle, it's smaller than the segments, wrong color, smaller than the segments, and the segments is also smaller than the big triangle, which is formed by 10 and 1. So let's verbalize this or write this out, which is sine theta times cos theta over 2. That is inarguably smaller than theta on 2, and that is unquestionably smaller than tan theta on 2, because we can just look at a unit circle and that's pretty much what it is. So if you really want to be annoying and accurate, you can also say that theta equals to is between 0 and pi on 2, so that's settled. Now is the old school algebra and rearranging the equations. Multiply by 2 and divided by sine. So that makes it cos theta is smaller than theta over sine theta is smaller or equals to 1 over cos theta. If you really like to write it that way, we can take the reciprocal just to write it out nicely. 1 over cos theta smaller than equals to sine theta over theta, because that's what we want to prove, right? But I mean, reciprocal doesn't really matter. We can just do it anyway. Once we got that, what we need to do is we have to take the limit on 3 sides together. So limit approaches 0 when cos theta, and that is smaller than limit when theta approaches 0, sine theta over theta, and that will be smaller than 1 over cos theta. Oops, sorry, I forgot to take the limit. That's bad. That's bad on me. I keep forgetting doing the limits. We'll have to do a bit more practice here. Smaller than limit when theta is equals to 0 and 1 over cos theta. What is this equals to? 1. Smaller equals to limit when theta equals to 0, sine theta over theta, smaller equals to 1. Then what else can this be? I mean, this value is bounded by 1 and 1. So therefore, by this setting, limit when theta approaches 0, sine theta over theta must be 1, because it's small. The lowest it can be is 1, and the largest it can be is 1. And yeah, we can look up on Desmos to verify the idea that sine x on x is indeed approaching that little point 1. So what is happening that Desmos is not doing quite a good job, because it's approaching that, but it can never be 1, because x cannot be 0, divided by 0, you get all kind of messy thing. But it's always helpful to look at the graph. Not always, but occasionally we can look at the graph and see what the value approaches. So both the graph and the limit, using some tricks, all suggest when taking the limit when x approaches 0, that little thing equals to 1.